Hey everyone, welcome back. Got a new video for you for chapter 13-4. Some new functions are being introduced here, but it's all related to what we've been doing. So everything comes together now with sine, cosine, tangent, and then the unit circle. We do have to review one quick thing though. So if you remember a little while ago, we talked about inverse functions. Remember, inverse functions are basically undoing what you did, right? So if I have a function f of x equals something, right? Let's say I plug in like 2, right? If I plug in 2 and get 4, the inverse is supposed to take what just happened and undo it, right? And work backwards. So that means that now if I take the inverse, which we remember we use the -1 symbol. If I take the inverse function and plug in 4, it should go backwards, right? And I should get 2. So remember, the inverse function is doing the opposite of what you were doing in the first place. And that's super important because chapter 13-4 is all about the inverse trig function. So we have sine, cosine, tangent. And now we're going to talk about the inverse of all of them, okay? So we do the same thing. We do it with a -1. Cosine, inverse cosine, inverse tangent. And this is almost, sometimes almost more important than the actual trig functions. And you'll see why when we apply it to like real situations. But yeah, so that's all it is. So remember the sine, cosine, tangent, you're taking of an angle, right? So I'm just gonna put parentheses here. You're taking of an angle. And then the inverse sine, cosine, tangent, you also will be taking of something in parentheses, but it's not an angle anymore, okay? So that's the first thing to consider. If we think about just sine, just one of them at a time, let's just do sine theta, right? Well, the sine of an angle, of course, is the opposite over hypotenuse, or as we learned from graphing in the unit circle, the sine of theta is also just the y value on the unit circle, right? Well, or opposite over hypotenuse, right? Well, what do we know? Let's look at the unit circle real quick, right? So we know from the unit circle, if the sine of theta equals the y value, let's just pick any random angle in the unit circle. Let's say 30, right? It's an easy one, 30 degrees. Sine 30 degrees equals the y value at the unit circle, which looks like it's 1/2, right? So, and we can rewrite this if we want to rewrite it in radians. 30 degrees is also pi over 6, which we also know from the unit circle. So same thing. So 1 is radians, 1 is degrees, okay? So if we do that, now, like I said, inverse functions work backwards, right? So if you take that same logic, that means that the inverse sine, we have to take what we got and go and undo and go backwards from what happened. So the sine of 30, let's just focus on degrees for now. The sine of 30 equals 1/2. So that means if I undo that means if I do the inverse sine of 1/2, right? Put parentheses just to look nice. It needs to go backwards. That means that's going to equal 30 degrees. So now you see what I was talking about. Instead of finding the length of a side now, which the sine, cosine, tangent, we were always looking for the lengths of sides, right? Now we're looking for the actual angle. So there are going to be times where you don't know the angle, and that's what the inverse sine, cosine, tangent are going to help you do. This is also the same as saying, there's also always 2 versions of this, right? Because we can do degrees or radians. So it could be 30 degrees. And this goes back to your calculator and what mode it's in, or a calculator you use on the internet, what mode it's in. You'll either get 30 degrees or you'll get pi over 6 in radian form, which will be most quick calculators will show that as a decimal. But obviously, if you use the unit circle, you're just going backwards. because since we know the sine of 30 is 1/2, that means if I take the inverse sine of 1/2, instead on the unit circle, instead of looking for y, right? This is looking for the y value. Since it's sine, inverse sine of 1/2, I know that the y equals 1/2, right? So the y equals 1/2. And if I'm doing the inverse sine, instead on the unit circle, all I'm doing is looking for the angle measurement in the middle of that circle that you all drew. I'm looking for that angle measurement that correlates to a 1/2 y, okay? Now, the thing is you'll get a bunch, you can potentially get a bunch of different answers, right? Because we know that, because it's an angle and we do the reference angle, you can get multiple answers, which is fine. It just depends what the situation is, right? Or what the triangle is. We'll talk more about that later, but that's pretty much that. So you're just undoing what you had. So same thing for cosine, right? If we do the cosine of, let's just do the same thing, 30. This is all from the unit circle. Cosine 30 or pi over 6. The unit circle says that's square root of 3 over 2. So now if we do the inverse, we're taking the inverse cosine of the side length, okay, of the x. Remember, square root of 3 over 2 is the x value, because it's cosine. So now to do the inverse cosine, we have to take the x value, because we're going backwards. And then we know what the answer is because we're just working backwards. But if you didn't know, you look on the unit circle, you say, okay, I'm doing cosine, inverse cosine. I'm doing inverse cosine of square root of 3 over 2. So I go to the unit circle, I look which angle has a square root 3 over 2 as an x value. And the first one you see is 30 or pi over 6. 30 degrees, pi over 6. Okay, so the cosine, regular cosine, you're getting the x, y value if it's sine, y over x if it's tangent. So the regular sine, cosine, tangent, you're finding out the length of the side, okay? Side lengths. Inverse cosine, sine, tangent, you're finding the angle. So completely different, right? But it's the same idea of working backwards. So sine, cosine, tangent helps you find side lengths, okay? The inverse is these help you find angles. Angles. The measurements of the angles, okay? And this is, of course, degrees or radians. So just, yeah, you could use either. Just it'll depend on the problem, of course. In real life, like real life word problems, you'll typically use degrees because that's what we measure in, like in construction and airplane flights and all that. But a lot of math problems will use radians too, so it's good to know both. So that's pretty much it. I mean, it's just really just knowing like when to do either is really important. So if you have a situation where like you have the angle, right? And let's say, I don't know, you're trying to look for the this side right here, right? We'll actually call this like A, right? Not a good A, sorry. So we're trying to look for that side. Well, you know that, based on what you know about the unit circle, sine 45, cosine 45, all of these, right? because you can get these from the unit circle. So now you're just using sine, cosine, tangent. But if you don't know the angle, right? Let's say like, I don't know, a plane is coming down, right? So you typically an invert triangle, like if you have an airplane here, it's not a very good airplane. Maybe it needs to know like what angle to come down to land correctly. Well, here's that angle. You know, you can create a triangle out of many situations. We know it has to come down like, I don't know, let's say this is, I don't know, 100 feet or something, right? It's just not a lot, but and it's, I don't know, like 300 feet away from the landing zone, right? Well, you don't know the angle in this situation, so what's the only way to do that? You know, you look at this and you're like, okay, well, I know 100 and 300. Based on this angle, 100 is the opposite, and 300 is the hypotenuse. So that means that I have opposite over hypotenuse, right? Well, so that means the sine of some angle equals 100 over 300, but I don't know the angle. So again, how to find the angle? Well, it's like getting rid of this sine, right? I don't know the angle, so in order to find that angle and put it by itself, I have to do the inverse sine because I know the side lengths. I'm trying to find the angle, so that's when I use the inverse functions. And I knew to use sine here because in relation to the angle, I had opposite and hypotenuse, right? So I knew I had to use inverse sine in this case, not regular sine, but inverse sine specifically. Okay. So really, yeah, again, it just boils down to what you know and what you don't know, and that's like all of math, right? Just figuring out, you have all these tools and all these functions, you have to use them based on what you know or don't know. And so to sort of talk about, so the unit circle, as we said, has a lot of different answers for all of them. Like if you look at the unit circle, you know, the sine of 30 equals 1/2. The sine of 150 equals 1/2. And that's it, right? So which answer do you pick? Well, it kind of depends on what the problem's asking, I think. So if you were to do like inverse sine of 1/2, well, technically there are two answers, right? 30 degrees or radians, and then 150 degrees or radians, right? Well, depending on the problem, maybe the problem asks you for, you know, maybe the problem says, well, it should be between 0. The answer should be between 0 and 90 degrees. Well, then obviously you're going to pick 30. Or if it was like the answer should be between 0 and pi over 2, that means the same thing, right? Because pi over 2 is 90 and 30 is pi over 6. Or a lot, you know, I think it comes down to like your intuition, because if you're doing a word problem specifically, most word problems, we only deal with angles that are less than 90. Rarely are we, you know, building things with a super large angle, but it happens. So you just got to figure out, you know, what the drawing is or what the problem's asking. In your book, though, if you look on page 951, it does kind of introduce this new domain and range for what to do, and you'll see this in your book. So what happens is they use this specific sine, cosine, tangent where it's capital. Okay. So if you see that, if you see capital sine, cosine, tangent, that means it has specific limit. Because remember, you know, since we're talking about angles in a circle, they could go on forever. If we're talking about, if you use the capitals, it's very specific. That's what your book does, at least. So I'll let you read that on page 951. It just says if you have capital Sine, you're only doing the part of the unit circle that's right here, the shaded in red part right here. So that would be from 0 to 90, right? Because we just looked at it real quick, from 0 to 90, and then from 270 to 360. Okay, so that's with capital Sine. With capital cosine, they want you to do just 0 to 180. So it only wants this part of the unit circle, this top part right here. So that's 0 to 180, as you can see. So it's all going to be, it's all going to be less than 180. And then for tangent, if you use a capital T, I think it's the same as the sine. It's the same as the sine. So they only want angles just like the sine that are 0 to 90 or 270 to 360. So that's just something to get used to from the book. I didn't really see that too often when I was, doing math, but it could be some sort of a new thing. So just look at the problems that you have to do in your book and just pay attention to when those are using capital letters. And that way, when you get two answers on the unit circle, like I said, you could have for the inverse sine of 1/2, right? So if I erase this a little bit, like inverse sine of 1/2, I said could be 30 or 150. But if I get rid of this and do capital S, like your book does, well, capital Sine means I can only do 0 to 90, like right here in the picture, right? I can only do 0 to 90 or 270, 360. So that means my only answer is actually 30. So my final answer is 30, or as we know, it's pi over 6. Okay. So yeah, that's that. And then practice some word problems maybe another time, but that's the inverse functions. Let me know if you have any questions. Read through the book for sure. It makes it a little bit more clear just for you to absorb how this works. And they have drawings to kind of help you too. So read through the book. Let me know if you have any questions. Thanks.